me dive in. One more fun fact, the attendees today, at least those who signed up, are 30% consultant, 30% founders, almost 30% engineers, 20% business owners, 10% product owners, 10% executives, and others as well. I think we have maybe a student or two as well. So I am going to make this useful for all of you, and hopefully you can take away something regardless of what background you're coming from. So here are some key terms that will pop up throughout the session. So we're going to talk about RAGs. We're going to talk about graphs. We'll talk about Microsoft Copilot and Glean as sort of examples. We'll talk about trends in the industry, enterprise adoption, the deployment timeline, project managers, project brain concept, the role of vector embedding, phase rollout, Extractive-Abstractive Spectrum, API MCP, and ROI problem, among other things. So we'll touch on a lot of topics. As I said, it will hopefully deliver value to different types of audience members here. So let's first look at what an internal knowledge base, or I may sometimes refer to as IKB, is using these queries that users would run or use cases. So if you are in the IT or engineering department and you're an on-call engineer, you may ask, have we seen this issue before that is popping up in production? What's the runbook for fixing it? They may ask this to the knowledge base. If you're in management and operations, which employees abandon their learning activities? And if you are a PO or PM, you may, here's a good quote from Reddit. Day to day, it's pretty simple. I open a terminal in my Vault. I paste a Slack message. I say, what do we know about this? The agent searches my notes, Jira tickets, decision logs, meeting notes, Confluence pages, and gives me a connected answer with links to the source files. If it finds something worth keeping, it writes a note in the right folder. So this is that project brain idea that I think a lot of you may be interested in, especially if you're a founder or PO or PM. For startups, another use case would be knowledge transfer to, or sometimes you can think of it as onboarding. So if you're a founder, transferring knowledge to a first non-founder engineer, and you have a bunch of commits in Slack, PRs and messages, you don't have to spend time organizing that information for the newcomer. You can use the knowledge base, or the newcomer can use the knowledge base to learn as they go. In the enterprise or mid-sized organization case, there's an interesting case of governed internal AI to displace shadow ChatGPT. So shadow ChatGPT meaning employees are instructed not to really use ChatGPT for sensitive information or any proprietary information. However, it sometimes convenience or whatever other reason really dominates, and the employee ends up using ChatGPT or some form of agent anyway. And if you have a good governed internal AI that does what any sort of public option would do very well, then you may see reduced rates of employees doing things they're not supposed to do. So that should give you a good sense of what it is, a knowledge base that is used internally. And let's go on to talk about why you should build an IKB, or why not something else. So most of you, I believe, are here in order to either build, if you're a developer, or implement an IKB for yourself or for others. So let's talk about why you might do that. If you research what enterprises are doing in order to leverage AI, so maybe there is an AI initiative that comes down from the leadership, and your team is putting heads together and thinking about what should we do. So here are some categories that come up if you research. Developer productivity, so think GitHub Copilot. Customer service, self-explanatory. Marketing and personalization. Marketing would be like asset creation. So I'm creating diagrams or brand assets in an automated fashion. You have internal knowledge operations, which is IKB. You have back office document processing, which are things like contracts or legal documents that may need to be processed in some manner. And there's an issue with internal knowledge base, and the issue is that of ROI. Marsh, McLennan, and Lin AI found 1 million plus team hours saved. McKinsey Lilly found users report up to 30% time savings. Glean, which is a company that specializes in knowledge bases, found via Forrester, an independent research company, that they saved 23.2 million from search productivity, 1.7 million from faster onboarding, 450,000 from reduced support requests. But all of these are heavily dependent on self-reported figures from the users. So there is a outstanding question that I think organizations have not really solved regarding measuring ROI for an IKB with hard numbers. So that's something to keep in mind when you undertake a knowledge-based project. If someone asks for, how did this improve the bottom line? It's actually quite difficult to measure that. However, there are good reasons to implement an IKB. One is that it's applicable to virtually any organization. You have your proprietary knowledge that needs to be organized for agentic consumption. You have, there's also an argument to be made where, a knowledge base is used for low consequence routine tasks, which is ideal for an agentic task, especially when you're undertaking something to begin with. It is not customer facing, so it's not as scary, and there's lots of resources online for how to tackle this. And thank you everyone for commenting and questioning in the chat. I will get to them at the end of the presentation. So I want to dive in now. We've looked at a reason why you might build or might not build an internal knowledge base. And an example of a knowledge base a fully fleshed out knowledge base that everyone may be familiar with is Microsoft 365 Copilot. So this is a knowledge base tool that Microsoft sells. It drafts emails, summarizes meetings, generates slides from Word doc, queries company files via RAG over your tenant's data. And it's sold as a $30 a month per user add-on to Microsoft 365. So let's talk about that term, RAG, real quick. I believe most of you here are probably familiar with it, but let's define it. RAG stands for Retrieval Augmented Generation. It's sort of the basis for giving an agent knowledge beyond its training. Right? So it has its set of training data that it learned from, but you often need to give it more knowledge, like proprietary knowledge or knowledge from the web. And RAG is a framework that allows you to give that knowledge to an agent. So we'll see how that works in Microsoft's Copilot's case. So if you look at the right-hand side diagram, we have the apps, Word, Outlook, Teams, Excel, PowerPoint at the top as a data source, right? So that the data has to come from somewhere and be retrieved by way of a user prompt, like summarize last week's email from Acme. So the user prompt initiates the process, and these are the data sources, and you retrieve data from them. What happens next is an orchestrated layer, something that coordinates the process, supervises the process, and it works with the data that is retrieved. So the first thing that it does is it finds the relevant emails, chats, documents, calendar events, SharePoint items, and it also considers permissions along the way. And there's a number of steps where permissions come into play. But it retrieves those emails and documents, determines which ones are relevant to the user query that is summarized last week's email from Acme. And then it sends that set of emails and documents to the model, which will generate an answer. So the part before generating an answer, all of that, finding the right chunk, finding the right document and filtering them and maybe modifying them is the process of augmentation. You're augmenting the model's knowledge with the found data. And then the model generates an answer so that it is answering the user's question. And the raw response of that generated answer would go to a post-processing layer that talks about something like that processes responsible AI, which is, for example, a company using AI to screen resumes might deliberately remove proxy variables like zip codes or names that correlate with race or gender to ensure impartial screening. And DLP right there it stands for data loss prevention. And of course, you have citation linking the answer to where that answer came from. And then the user receives the answer. So there's a problem with Microsoft Copilot specifically. They've been around for a couple of years now, and the reception has never been very good. And it's worth examining why in terms of our use case of building or implementing a knowledge base. So NPS stands for Net Promoter Score. That's that annoying survey that you get once in a while that goes like on a scale of 1 to 10, and would you recommend this product to a friend? Then you answer 7, and that becomes a positive score. You answer 3, it becomes a negative score. The sum total is NPS. So you can see it went from negative 3.5 in July of 2025 to negative 24 in September to negative 20 in January of this year. So why are users so dissatisfied? 44% of lapsed Copilot users cite distrust of answers as the primary reason for stopping use. So you get an answer, you get citations, you can see where it came from, but it's hard to trust it, especially if you're doing an important work at your workplace, and Gemini, Claude is spitting out this answer. You can go into the URL and check, but is it at that point, is it really time saved? Should I just do what I've always been doing, right? So distrust of answers is a huge problem in this Microsoft world. So now let's look at one more. Glean is a newer RAG specializing company that is doing much better than Microsoft. So Glean is a vendor. It's a vendor product that you can purchase as an organization, typically geared toward enterprises because it's like a minimum of 150 seats and like 50 seats per user per month. So it's quite expensive. But if you're an enterprise and you're undertaking this knowledge base, which is a very difficult project, you may consider a vendor like this. Why are they better? And I think we can objectively say they're better. Let's look at that. So examining the source systems, so earlier we were calling it it's talking about the Word and Outlook, and those are the source systems for Microsoft native applications. Now we have anything, Slack, Drive, Confluence, Jira, GitHub, Salesforce, over 100 connectors that connect Glean system to these data sources. And the connectors are doing several things. API, which is the native interface for these systems. You're authenticating into those systems, and then you're checking permissions, and it's also tracking changes. So it's doing CDC, it's doing a synchronization work. So if there's a new message in Slack, it's picking that up, right? If you don't refresh that, actually, this is one of the primary complaints of Glean. I think it's on the an hour or so delay sometimes, where new documents, edits to documents, new messages, new emails are not getting picked up. But that is an important aspect of what a connector does. And you retrieve information from these data sources using the connector. Let's see, content, metadata. ACLs are access control lists. That's related to permissions. And zero copy. So Glean does not copy the information that's in the sources to somewhere else. if you think data engineering, you would take the raw data, you would shape it in some way, store that intermediary form somewhere, and then maybe another gold zone form somewhere, right? Glean tries not to do that. It leaves the data in the source side, therefore the source of data is clear, a source of truth is clear. Full source ACLs alongside content, we talked about that. Per tenant storage. So here's where things get a little interesting. So we have lexical index. That is something that all of us are already familiar with, which is keyword search, right? You type a term in Jira and you get a set of pages back. That is the lexical index. And it runs alongside something like a vector index, which is what you may have heard of in the context of a RAG. So RAG and vector index, embedding a set of text into the database in the form of a vector, sort of like an AI model itself, is something that a RAG typically implements. But what's interesting here for Glean is the per tenant embedding, the custom embedding, right? And what that means most likely, Glean reveals a lot of its architecture, but it sometimes hides things for obvious reasons. But most likely the custom embedder is using things like learned terms and synonym tables from the business that's purchasing the product. So if it has specialized terminology for marine biology, that, maybe there is CAR is an acronym that they often use, and the model needs to know it's not talking about a car, right? So things like that can go into the embedding process. And the third box, the rightmost box of that third box, the knowledge graph, that's also very important and very applicable to RAGs in general, knowledge bases in general, is it encodes entities and relationships. And what that means is entities are things like people, a person's an entity, a document is an entity, and even activity, who edited the document, or somebody authored the document. That activity itself is also an entity. And you link those entities via relationships. So Jane owns this document, this ticket links that PR, this channel discusses that project. And once you have this entities and relationships, you can do something really cool. So co-occurrence as evidence. If the term Atlas and Atlas migration are both mentioned by the same 5 people in the same Slack channel and linked from the same Confluence space, that's evidence that they're the same thing, right? So it's actually solving one of the, not completely solving, but helping to solve one of the challenges of normalization, of knowing which two things that are spelled differently, that are phrased differently, are actually talking about the same thing. You gather evidence from relationships, right? So I think that's a powerful takeaway from this architecture. And then you have some caching and hybrid retrieval, which is just talking about the fact that we use the keyword search, we use vectors, we use graphs. So it's a hybrid form. There's ranking, which of the chunks are more relevant than the others. And it branches off because there's layers of permissions to consider. At the point of retrieval, this person, Jane, may not retrieve this document, right? So that if that's the left branch, the right branch would be the answering agent or synthesizing agent who is looking at all these documents, also may not give Jane information from this document, right? So there's two levels of permission checking that you have to do, which is why it branches down there. And then the answer is shown to the end user. So you can see it made significant improvements to the Microsoft structure through a number of ways. And we kind of have a decent idea of what a knowledge base, a RAG-based knowledge base looks like in production. Now let's step back a little bit and think about trends in the enterprise landscape. So here is a VentureBeat article called "The Retrieval Rebuild." why hybrid retrieval intent tripled as enterprise RAG programs hit the scale wall. It's a lot of terms there. We talked about some of them, right? We talked about what a hybrid retrieval is. We talked about what a retrieval is in the context of retrieval augmented generation. So people are adopting hybrid mode. Enterprises are adopting hybrid mode for reasons of scale, right? So enterprise intent to adopt hybrid retrieval tripled from 10% to 33% in a single quarter, meaning whatever they were doing before the hybrid wasn't working, right? You need to combine all these approaches in order to make it work. And the standalone vector database category is under pressure. So if you're just converting text into vectors, it's not sufficient. So VV8, Melvis, Pinecone quadrant, each lost adoption share across the quarter in the VB Pulse data. Custom stacks and provider native retrieval are absorbing their displaced share. And this note about custom stacks is also interesting. I think we'll get into it in the subsequent quotes. Managing a separate vector store, graph database, and relational system just to power one agent, which is the knowledge base, is a DevOps nightmare. So instead of having a vector store from Pinecone, a graph database from maybe like a Neo4j graph database, and a relational system from AWS, and then you're trying to make them all work together, maintaining all of those, it's too much work. It's almost as much work as if you just built it yourself. That's kind of what that's getting at. And the custom stack rise to 35% is not a rejection of managed retrievals. So you still have vendor products, but it is a consolidation response from engineering teams that have hit the limits of assembling too many components. Two enterprises building on Quadrant show why purpose-built vector infrastructure still wins in production. So And AI builds patent litigation infra and runs semantic search across hundreds of millions of documents. Glassdollar, a startup that helps, runs an agentic retrieval pattern across a corpus approaching 10 million index documents. So we're talking about scale, right? If you are an organization that has 10 people, it's not really relevant, right? This particular point is not really relevant. But if you are working in an enterprise, and many of you are, and you're trying to introduce a knowledge base as a potential way to rise to the challenge of an AI initiative, then this is actually quite pertinent, right? So why enterprises say they need a dedicated vector layer. So what this is saying is, once you hit a scale, the most reliable thing in this structure is that middle box in the third box, the vector index. When you hit tens of millions of documents, right? The fastest, the most consistent retrieval mechanism that you can rely on is actually the vector index that everyone started with. And then you can layer on lexical index and graph and other things on top in order to better the performance. But the vector index needs to be the bedrock, is what people are finding. In January, the top reasons were access control complexity and retrieval precision. But by March, operational reliability at scale became the primary reason people argued in favor of a vector layer. And I also want to touch on a couple of narratives that went around earlier this year and late last year. The first narrative is that long context windows, models capable of processing hundreds of thousands of tokens in a single prompt, would render RAGs or vector-based systems unnecessary, right? So instead of, there was a narrative that said, you don't need a database. You can just load your entire corpora of documents to the agent, and it will work magically because the model's context windows are growing larger and larger. So it is able to access all that data at once. That was a myth. It did not pan out. And people are observing this. So that people holding that position collapsed from 15% in January to 3% in February. Now it's at like 6%. But so people are finding. And the second sort of, narrative that didn't pan out is that agentic memory systems, you may have heard of Aramis memory system, or memory is just a hot topic, right? Agentic memory systems which store what an agent learns across sessions rather than retrieving it fresh each time would absorb the knowledge access problem entirely. So once again, it's trying to say you don't need a RAG, you don't need an IKB, you just need to give the agent a memory system. And this is more of a misunderstanding than a narrative that lost, which is that memory addresses session continuity and agent context over time, which is a different problem than high recall search across millions of changing enterprise documents. So keep that in mind if your coworker or somebody on YouTube is talking about, is arguing for why you don't need a RAG. The dominant sort of trend right now, at least, is that you do need it. And something interesting also from this article, if you look at the table on the left bottom, we do not expect large-scale RAG deployments row. It rose 12 points between January and March. And what that means is people are learning that building a knowledge base or any RAG-based systems is way harder than it appeared at the beginning. I think there's a quote later that says it's harder than machine learning or implementing a machine learning pipeline. So keep that in mind as well. Now I want to touch on a different problem, which is the, say you build something, right? How do you roll it out? How do you roll it out in a way that avoids, problems like this, where in Microsoft, users are reciting, I don't trust these answers. I'm not going to use it. And they're likely not going to trust your answers at the beginning because you just built it and it's not very good yet. What you're going to need for sure is feedback from users and a way to iteratively better the system. But that's got its own challenges. So here's a quote from a 2015 study. So this is pre-AI era study. It's talking about how people lose confidence in algorithms more quickly than in humans after seeing them err, even when the algorithm objectively outperforms the human. So once you see a system, a code, a application do something wrong, just a couple times, right? People lose confidence. And like a lot of people I know who are skeptics are essentially like having the same reaction that's described here, where you ask a question to ChatGPT, you get the answer that you did not exactly want a few times, and you stop using the tool instead of trying to work with it or trying to learn it or trying to engage with it. So common failure modes, trust collapse from weak citations. I think this one everyone probably is aware. Whenever you use an AI model to answer questions, you want to cite, and you want to have a good, strong citation, always cite type of either system prompt or enforcement. And there's also stale corpus decay. So wikis and Confluence rot, meaning if you work at a company, and you probably already know, if you go into your Confluence page and looking for a certain topic, there is 3 contradictory documents that are none of them are marked OBE. There's one from last year, one from 2 years ago that are all kind of talking about the same thing. Which one's right? And turns out none of them are right. None of them are up to date. So you have to go to some other human to find the answer. So that problem is not a system problem, right? That's a workflow problem. That's a human problem that manifests in internal wikis and Confluence pages. But when you put a knowledge base, an agentic power system to that, what happens is these issues get really amplified. You see the problem instantly, whereas before you used to see the problem over the course of half a day. And when you see it instantly, it kind of seems like it's a system problem, a problem of how you design the knowledge base, as opposed to the underlying knowledge that's wrong. So obviously we need to consider a context-based approach when rolling out a knowledge base. So what might an MVP for a knowledge base look like? And I want to offer a Reddit question by way of answering that question. So here's a question from in our product management. So question from a PM asking, how are you creating a project brain with AI? PRDs, research meetings, data. Curious how other PMs are handling this. We use Cloud internally with access to Google Drive and our data warehouse. Right now, I keep separate chats per project, but context gets fragmented. Research, PRDs, meeting notes, user interviews, experiment results, decision logs, etc. I'm trying to figure out the best way to create a persistent project brain so AI can pull relevant context across all of it. Are you building a real RAG setup, embeddings in vector database, or are you just relying on good document structure and drive search? Or are you maintaining a living master doc per project? So we talked about that first bullet, but the second one and third one are really just talking about loading or giving the agent access to all of your files without having a database, right? If you have a good file structure, maybe the agent can efficiently search it without needing a database. So that's the question being asked. And the best answer there is what answers the MVP question. So the replying user says, I use a Jira CLI, and CLI is just an API. It's how you get data out of Jira, how we always got data out of Jira before AI ever existed. So I use a Jira CLI to pull everything locally. Then I add all sorts of notes by hand and also from Slack, and using Cloud Code to summarize things. I load all of this into Obsidian, which is just a note-taking app. I load all of this into Obsidian folders using its native method. Then I create some agent files for specific purposes, like checking strategy, comparing against competition, rubber duck conversations to understand complicated engineering topics, writing or refining planning docs, and Jira tickets. Important, make sure that agent files have very strong and strict advice about facts and assertions. Don't let the LLM improvise. My day-to-day is a completely different experience these days compared to my previous 15 years as a PM. And no, I am not fully comfortable with all of this from a political or philosophical standpoint. So what that's really describing is, instead of building, something like this, right, either of these, where we have a knowledge base, or we have a set of source systems, we try to crank it through a machine to get a digested answer in a general sense. So any user query it needs to satisfy, right? Instead of doing that, this user is identifying a few things that she does every day, all the time, right? She has to check strategy. She has to compare against competition. She has to write and refine planning documents. How can we automate that instead of trying to automate everything at once? And that, I think, is a very good MVP model. And I say MVP because obviously down the road, you do want to develop a RAG-based knowledge base if it's going to be useful for everyone. However, when you're rolling out, what's important is this trust issue, right? If people lose confidence, and they lose confidence when the answer is wrong, then focus on a few that deliver the most value and have the answer be always right? So that's the MVP that this is arguing for. And if I can just add a touch of architecture there as well, you can have a router agent, an agent that chooses the appropriate sort of sub-agent that specialize in either domains like this, just domains of Jira, Confluence, Bitbucket, or they can specialize in one of these tasks, a strategy sub-agent, a checking competition sub-agent, and so on. And what this architecture solves is there's a tool bloating problem that I'm not going to go into here. And the parent seeing only 5 sub-agents solves the sort of tool selection problem, and each specialist gets a clean context. This is just another way of putting what I just said. I don't need to worry about complicated things like RAG or vector DBs or embeddings. The context window in current models is big enough that reading files directly works fine for her scale. For a PM scale knowledge base, a few hundred nodes, file search and grep is plenty. Other people are arriving at the same setup independently. And quick note on beyond MVP. I think we have about 10 minutes, so I'll wrap this up pretty fast. So this post was also very good, explaining a typical sort of pitfalls, set of pitfalls that people encounter when they try to build an internal knowledge base, and what to do about it. So number one, document quality detection first. You score a doc based on its quality, and then you retrieve accordingly. And then number two, you build hierarchical chunking, meaning you don't divide a large text by the number of words. You divide it by the hierarchy that is present in the text. So if there's a heading, if there's a section, if there's a paragraph, that's where you would divide the text. Number three, metadata is more important than embeddings. So don't focus on, getting a better model or improving the customization of a model in order to embed the vectors better. Instead, focus on generating good metadata, good sort of set of data about your data. And that really helps with the retrieving. Number four, pure semantic search fails. So this is just saying you do want hybrid. Number five, open source models win on enterprise constraints in terms of cost, data sovereignty, and terminology. So data sovereignty is probably the most important thing there, because a lot of regulated industries, the data, you don't want it to leave your domain. So instead, use open source models locally in order to contain that data. Number six, tables are a hidden nightmare. So if you have documents with tables, those tables need their own special attention and own special pipeline. Number seven, infrastructure beats model quality. So once again, don't focus on models, focus on things like concurrency, for example. If several users are hitting your knowledge base at the same time, what happens? Ask questions like that. Bottom line, here it is. Enterprise RAG is more engineering than ML, machine learning. And I do want to mention one other thing here, which is extractive-abstractive spectrum. So the answer that you give to the user, they ask, can you summarize something, or what happened here? The answer that you give can be more synthesized, more generated, or less synthesized. So you can give them, at the far end of extractive side, you can just give them URLs, right? You can give them links, you go look at it. Or a little closer to the middle, you can give them URLs and maybe what the agent thinks is the relevant part of the text, but you're giving it verbatim instead of paraphrasing or instead of combining all sorts of information, right? And then all the way at the abstractive end, all you're giving is the answer in a few words, in a paragraph, and not even including citations, which you obviously don't want to do. So depending on your use case for the knowledge base, do think about this spectrum. And in order to enforce verbatimness, you can implement deterministic eval instead of LLM eval.